Okay, so today's notes are on solving systems with substitution. So our content objective is going to be to solve linear systems algebraically using substitution, and our language objective is to use correct terminology when explaining the process of solving linear systems using substitution. So just as a quick reminder, there are 4 ways to solve a linear system. Yesterday we did graphing. We did that one. Today we're doing substitution. So this is today what we're focusing on. And then tomorrow we're going to do elimination. And we may do a quick day with calculators and learn matrices, but the ones I want us to spend the most time focusing on are substitution and elimination. So substitution is going to be super, super important, so I want to make sure you really understand it. So we're going to do several examples in these notes today. So our example that we're going to start with asks, what is the solution of the system of equations and our system is 3x plus 4y equals 12 and 2x plus y equals 10. So these are our 2 equations, and we're solving for the solution using substitution. So just a reminder from yesterday, we know the solution is the point where they intersect, or when the x and y coordinates can be plugged into either equation and generate a true equation. So we're looking for the x and y coordinates that can be plugged into both to make a true equation, which is the point of intersection of the 2 graphs. So for substitution, the first thing we're going to do, step 1, is isolate one variable from one equation. So a little side note here, or a little trick or thing to remember, is you can solve for any variable in either of the equations. So any will work. So choose the simplest to solve for. So if I'm looking at these 2 equations, I want to choose the simplest one to solve for. And y, if you look here, is already, there's no coefficients there, so all I need to move is the 2x. So I'm going to number these equations so I can refer to them. I'm going to choose equation number 2 to isolate one variable, because I know that will be the easiest one to isolate. So I'm going to write, I'm choosing equation number 2, and I start with 2x plus y equals 10, and I'm going to isolate y by subtracting 2x from both sides. So I get y is equal to negative 2x plus 10. So now I've isolated y. I solved for the simplest one. So step 2 is going to be to substitute the new equation. So the one I just got, y equals this. Substitute the new equation into the other equation. So I have my other equation, equation 1, is 3x plus 4y equals 12. And here, I'm going to take the value that y is equal to, so I know y is equal to this, and I'm going to substitute it into this y. So I'm substituting this y value into this y. So I'm taking my whole y equation and plugging it in for y. This is the key step of substitution. I'm substituting this new expression in for this y here, since I know y is equal to this. So I substitute it in. I get 3x plus 4 times negative 2x plus 10 is equal to 12. So now I've substituted that in. Now I have an equation with only one variable. So that's the goal. When I have an equation with one variable, then I can solve for that variable. So that's exactly what I'm going to do. I'm going to solve for variable, or the variable. in my new expression or equation. So I'm solving for the new variable, or for the variable in the new equation. So the first thing I need to do here is distribute the 4 in. So I have 3x minus 8x plus 40 equals 12. And I'm going to combine my like terms here. So I have 3x and negative 8x, and I get negative 5x plus 40 equals 12. I'm going to subtract 40 from both sides. I have negative 5x is equal to negative 28. So 12 minus 40 is negative 28. And my last step is to divide by negative 5, and I get x is equal to 5 and 3/5. So I know 5 goes into, 5 and 3/5, which is the same as 5.6. So I get 5.6 for x. I've solved for one of my variables, but I know I'm looking for both an x and y value, so now I need to solve for my other coordinate and my coordinate point, so I need to solve for the y value. So the way I'm going to do that in step 4 is to substitute new value, or the new value, into one of the original equations. So now I know x is 5.6. I can plug it into either one of these to solve for my y value. So now I have x, I need to solve for y, so I'm going to plug in x to one of the two equations to solve for y. So I'm going to choose to plug it into my second equation, so number 2. So I have 2x plus y equals 10, and I'm substituting this value in for my x now. So now I have 2 times 5.6 plus y is equal to 10. 2 times 5.6 is 11.2 plus y is equal to 10. I subtract 11.2 and I get y is equal to negative 1.2. So now I have both an x and y coordinate. So my last step is to write that coordinate that I've solved for. That is my solution. So I'm going to write my x coordinate is 5.6 comma negative 1.2. That is my new coordinate, and I can box it in. That is my solution. You can also always plug back in both to solve and check your answer, but I'd rather do another example with you right now of the process. So if you'd like, you can plug it back in to check, but I'm going to move on to a quick check now. Make sure you have this all written down. I'm going to turn the page. All right, so our quick check that I want us to do together is, again, solve the system for x plus 3y equals 5 and negative 2x minus 4y equals negative 5. So I want you to try it on your own, follow the steps of the process I just gave you. Pause it if you need to. I'm going to go over it now. So again, I'm going to start by choosing an equation to solve, or the simplest one to solve for a variable. I'm going to number these so I can refer to them again. So I'm going to choose equation 1, and I have x plus 3y equals 5. I'm going to solve for x by subtracting 3y, and I get x equals negative 3y plus 5. Now I'm going to substitute that into equation 2. So I have equation 2 is negative 2x minus 4y equals negative 5. Again, this whole thing is my x value, so I'm going to substitute it in for my x value. So that whole expression is going in for my x, and I now get negative 2 times negative 3y, plus 5 minus 4y equals negative 5. And now I'm going to solve out for y. So now my next step is to solve out for y. Negative 2 times negative 3 is positive 6y. So I'm distributing my negative 2 in. Negative 2 times 5 is negative 10. And then I have minus 4y equals negative 5. I'm going to combine my like terms, and I get 6y minus 4y is 2y minus 10 equals negative 5. I add 10 to both sides, and I get 2y is equal to 5, positive 5. And my last step is to divide by 2. My last step is to divide by 2, and I get y is equal to 5 over 2. Now my next step, I have my y value. I'm going to plug it back in to an equation to solve for my x value. So I'm going to use my equation number 2 again. So I'm going to have negative 2x minus 4y equals negative 5. And I'm going to take this value, plug it back in for the y over here. So I have negative 2x minus 4 times 5 over 2 equals negative 5. And I get negative 2x. 4 times 5, or negative 4 times 5 is 20, divided by 2 is 10. So I get minus 10 equals negative 5. So if you didn't catch that, negative 4 times 5 is 20, divided by 2 is 10. So I have negative 10. I add 5 to both sides, and I get negative 2x equals 5. So x equals negative 5 over 2. So my solution for that problem is negative 5 over 2, comma, 5 over 2. And that is my coordinate point for that problem. All right, make sure you write down any questions, comments, concerns you have on that. Let's do one final one together. One final question, or one final quick check. So we're going to solve the system for 2x plus y equals 20 and 6x minus 5y equals 12. Pause it, try it on your own. I'm going to go over it now. So this is equation 1 and equation 2. I'm going to take equation 1 to solve. So I have 2x plus y equals 20. I subtract 2x and I get y equals negative 2x plus 20. And then I'm going to solve out, or I'm going to substitute that into my second equation. So I have 6x minus 5y equals 12. And I'm taking this whole thing and plugging it in for my y value, or substituting it in for my y value. I get 6x minus 5 times negative 2x plus 20 equals 12. I distribute my negative 5. I get 6x plus 10x minus 100 equals 12. 12. Now I'm going to combine my like terms here, and I get 16x minus 100 equals 12. I add 100 to both sides, and I get 16x equals 112. I divide by 16, and I get 7. So if you didn't know that, you could plug it in a calculator or take some time out, solve it with mental math. But 112 divided by 16 is 7. Then I'm going back to one of my originals. I'm going to choose the first one, but it doesn't particularly matter which one you choose. So I'm plugging it back in here. So I have 2 times 7 plus y equals 20. So I get 14 plus y equals 20. So y equals 6. So if I subtract 14, I get 6. So my coordinate point will be 7, 6. All right, that's all for these notes for today. Make sure you write down any questions, comments, concerns you have so we can go over them together in class.